Okay, go through the possible true false. It says number one, if angles A and B are supplementary, and angles B and C are supplementary, then angles A and C are supplementary. This is actually a theorem. Um, it's called the congruent supplements theorem if you want to look it up. If you don't remember the theorem, no big deal. Because all you have to do, okay, A and B are supplementary, B and C are supplementary. So A is supplementary to B, and B is supplementary to C. And we want to know what's the relationship between A and C. Do you already know what it is? A and C are going to be congruent, thank you. Not supplementary. This is going to be false. Let's say that B is 50 degrees. Measure of angle B is 50 degrees. That means the measure of angle A, since they are supplementary, would be 130. Since C is also supplementary to B, that means that C would also be 130. So by the congruent supplements theorem, that would be false. It says if angles A and B are supplementary, B and C are supplementary, then A and C must also be supplementary. False. A and C, if I asked you to correct it, A and C would be congruent. Number two, if angles A and B are complementary, and angles B and C are complementary, then angles A and C are congruent. This is called the congruent complements theorem. You could prove it the exact same way. Angle A and C are congruent. What do you think? True, false? A and B are complementary. B and C are complementary. A and C are congruent. What do you think? Andrew Griffith. True. That is true. It's called the congruent complements theorem. True. Number three. If parallel lines are cut by a transversal, let's draw that. If parallel lines are cut by a transversal, then same side exterior angles are supplementary. Same side exterior. Are those supplementary? What do you think, Cody? Yes, they are. That's true. Let's go through all 5 scenarios. Same side exterior, which we just did, those are supplementary. Same side interior, which would be either these two or these two. Same side interior, also supplementary. Rewind. What's the name of those? Anybody? Alternate interior, they are congruent. These are also congruent. Those are called alternate exterior. And the last type of congruent teeter, we did alternate interior, alternate exterior, same side interior, same side exterior. What's the other congruent one? Corresponding. This angle and this angle. Or this angle and this angle. There's 4 sets of corresponding. Those are also congruent. So on the test, if parallel lines are cut by transversal, same side exterior angles are supplementary. True. Test at number 4. All right angles are congruent. True. Why are they all congruent? Because they all measure 90 degrees. Okay, that's your proof, right? What she just said is pretty much the proof and reasoning behind it. They all equal 90 degrees. They're all congruent. Number 5, if 2 angles are congruent and supplementary. Okay, stop there. Don't read anymore. Just think about that scenario. If they're congruent and supplementary, first off, if they're supplementary, linear pair. Then start thinking linear pair. They add up to 180. But if they're also congruent, those won't be congruent, right? This one's small and that one's big. There's only one scenario where these 2 angles would be congruent. Megan, what would that scenario be? Because this would be like 70 and 110. They're supplementary, they add up to 180, and they're the same size. They would both have to be, how big? Right, straight up and down. That's the only way for them to be congruent, is if they are both 90. So, this says, if 2 angles are congruent and supplementary, then both angles must be acute angles. False. Both angles must be 90-degree angles. Number 6. In the same plane, if 2 lines are perpendicular to the same line, then the 2 lines must be parallel. If 2 lines are perpendicular to the same line, let's draw it. 2 lines are perpendicular And perpendicular means they form right angles, right? If two lines are perpendicular to the same line, then they must be parallel. If they're perpendicular, you've actually got four, not just one, two, but actually four 90-degree angles here, 90-degree angles there. Question is, are these two lines parallel? This line and this line. Brandon, what's if the ones I marked, let's just use these. What's the relationship between this angle and this angle, Brandon? Are they alternate interior, alternate exterior, corresponding, same side interior, same side exterior? Corresponding. They're in the same place. Does everybody see that corresponding angles are congruent there if they're both 90? If corresponding angles are congruent, are the lines parallel? Yes. Did we have to use that to prove it? No, if you want to. Just for kicks. Those are the same. That's also 90. Alternate interior angles are the same. This one's also 90. So alternate exterior angles are the same. They're all the same. Yeah, they're parallel. Okay. So that would be, let me read it again. If in the same plane, if two lines are perpendicular to the same line, then they must be parallel. True. Notice number 7's from last chapter. Or actually, first chapter. Vertical angles are always supplementary. Tirsa, are vertical angles always supplementary? No, they are always. Careful, vertical are. Here's vertical. Let me draw a picture of vertical. This angle and this angle, those are vertical. They would always be congruent. Okay? They are not always supplementary. Now, here's what throws people off. These two angles, are they always supplementary? Yes, but that's not vertical angles. Okay, that's a linear pair. These two angles are the vertical ones. These two angles are the vertical ones. Vertical is always congruent. Next one. The symmetric property of equality states that A equals B and B equals C, then A equals C. I don't think that's symmetric, correct? Taylor, that's not symmetric. What property is that actually over here? A equals B, B equals C, then A equals C. What property is that? Transitive. That's not symmetric. Symmetric property, just in case I switch this up and give you something different on tomorrow's test. The symmetric property, again, think of symmetry, not reflexive. Reflexive, you're thinking about a mirror, right? Here's your mirror, you're equal to yourself. That would be A equals A. What's on one side is the same as the other side. That's reflexive. Symmetric would be if A equals B, then B equals A. Here's why we use symmetry. If you get down to the end of a proof and you have 3 equals X, and you want X equals 3, you can flip that around. That's the symmetric property. The last true false. Point B is located on line segment AC. Stop there. Point B is located on AC. Here's B. It's located on line segment AC. Next part. Between the 2 points. By the segment addition postulate, and I think this is chapter 1 as well. I go back and I put a lot of old stuff on these tests. By the segment addition postulate, we know that segment AC plus AB is BC. AC plus AB is BC. Do we know that that is true? No. No, that's just confusing. Trevor, take the segment addition postulate and actually apply it there. We know that AB plus BC, good. That's what the segment addition postulate says. This part plus this part is equal to the whole part. Okay. So that one would be false. Multiple choice. Let me explain what a negation is. I'm glad we're going over this. I've been telling you to not things. To find the inverse of something, you not the first and you not the second. Which, by the way, make sure on the test tomorrow you know what a converse, an inverse, and a contrapositive is. That will not be given to you. It's not on your formula sheet. You cannot write it on your formula sheet. No converse, inverse, and contrapositive. To find the inverse, listen to what I'm saying. To find the inverse, you find the negation of the front and the negation of the back. A negation is simply the not statement. That makes sense. So what is the negation of the statement, the sun is shining? What do y'all think? The sun is not shining. Okay, C. And a lot of people is going to make the statement, oh, well, that means it's cloudy. That's the same thing, right? Don't overthink these. Hey, please do not overthink these. Guys, if it's cloudy, or just because the sun is not shining, it could be nighttime, right? Does not necessarily mean that it's cloudy, but the sun's not shining, period. What is the inverse? Okay, to find the inverse, we not the front, we not the back. If the original statement is, if two triangles are not similar, we got not that. How in the world do you not if triangles are not similar? Oh, that's easy. You put if triangles are not similar. Correct? That is exactly right. The two triangles are not similar. What does not similar mean? They are similar. Why? Why? It's mathematical, isn't it? That's it. That's negative. And not, that's like a positive. Okay? Very mathematical. If two triangles are not similar, that means if two triangles are similar, their corresponding angles are not congruent. Which would be, they are congruent. So the inverse of this would be, if two triangles are similar, their corresponding angles are congruent. Which would be, I believe A. If two triangles are similar, their corresponding angles are congruent. Which is A. Move along. Number 13. We're asked to find the converse of the statement, if Bob does his homework, then George gets candy. I believe this was one of our warm-ups one day. Converse. Remind me, Austin, Reed, how do we find the converse of a statement? You're going to flip the front with the back. So instead of if Bob does his homework, it's now if George gets candy, then Bob does his homework. If George gets candy, then Bob does his homework, D. Number 14. What is the contrapositive of the statement? If I am tall, then I will bump my head. In order to find contrapositive, you not and you flip. You find the negation of each and you flip them around. So if you want to find the negation first, is not tall implies not bumped. And then flip them around, not bump implies not tall. So if I do not bump my head, then I am tall. No, that's not right. If I do not bump my head, then I am not tall. B, final answer. Next problem says, based on the diagram, which statement is true?